This last video in tutorial 1 is going to be on applications of functions, as well as, I think the title is modeling applications of functions. So I just put it under the heading applications of functions. But what it is that you're going to be given an equation that's an application. So it's going to apply to a scenario, and you're going to be asked to solve for things. So for example here, this is an application of windmill power. Under certain conditions, the power P in watts per hour generated by a windmill with winds blowing V miles per hour is given by this equation. First thing I want you to realize is that if you are reading this, this is power as a function of wind speed, right? Because it's generated by a windmill with winds blowing miles per hour. So miles per hour is a unit for speed. So this is power as a function of wind speed. So what we can then get you to do is use this application to do something like find the power generated by 35 mile per hour winds. They are telling you that V is 35. In other words, you're finding the power when the speed is 35 by plugging in V is 35. And then you plug it into your calculator. This one I'm not doing in my head. So 0.015 times 35 cubed gives me, now it doesn't say what to answer to, so I get 643.125. Anybody taking a science course, maybe you want to answer to 2 sig figs, like 640. You'll just have to look at the back of the book. When they don't specify, I won't take marks off no matter what you give me. But it is good to know that this is the power. So this is the power in watts per hour. So when the wind speed is 35 miles per hour, your power output for this windmill is 643 watts per hour. What wind speed will generate approximately 50 watts per hour of power? Can you pause the video and think about, in this question, what are they giving you this time? Are they giving you wind speed, or are they giving you power? Hopefully your answer to this was that they are giving you power. So in this case, they are telling you that power as a function of wind speed is 50. So what you're going to do is, in the equation, power as a function of wind speed, you're going to put in P of V is 50. Now people always get really confused with this. They always want to just plug in for P, and they're like, it's 50 times V. I'm like, no, this isn't a multiplication. I wish they could use a different symbol for this, but that's pretty much all that's available between a computer and people writing. This is power. It's just power as a function of wind speed, so you're going to replace all of it. So 50 will equal 0.015 V cubed. And then we'll solve for V cubed by first dividing by 0.015 on both sides, which gives me 50 divided by 0.015. Whew, gives me an awful number. So I'm going to just keep it as this. Now, if you've already plugged it into your calculator, that's great. It should be 3,333.333, but I can't write it down without rounding, so I'm just going to keep the whole thing. And then whatever you got here, you're going to take the cubed root. So I already have 50 divided by 0.015 in my calculator. So now I'm going to hit cubed root. So I have a cubed root button. If you don't, you could use your X root button where you type 3 and then X root. But I'm just going to type cubed root, and then I'm going to do cubed root of my answer. So in my calculator, I hit alpha answer, and it's taking the cubed root of what was previously written on my screen, and I get V is equal to, and again, I didn't tell you what to round to. I'm not going to write everything down though. Everything's kind of been in 2 digits here, so let's just do 15. So 15 miles per hour. So approximately, right? Anytime you give an approximate answer, you're going to say that it's like a dot on top or a squiggly line, but we'll say approximately 15 miles per hour for the wind speed. The next part of this note is that I gave you the model and then we used it. In the next part, I'm just going to help you remember, because this should be review, how to set up a function in terms of an application. In other words, I'm not going to give you the equation. So in these ones, we're just going to set up the equation. So for this one, we're going to use an application of functions for a triangular stage. And we are going to have a stage being made so that the height is 5 more than 3 times the base. And we're going to express the area of the stage as a function of the base. So the first thing I notice here is, what am I modeling? Well, I'm modeling area. Area of a triangle. So I would look up the equation for the area of a triangle, which is 1/2 base times height. But I want my equation to be area as a function of base, meaning I can't have two variables. I can only have one, and the variable that I want is the b. So to write area as a function of the base, I can only have a b, which means I need to replace the h. Well, they gave me this sentence here to replace h. They said that the height is 5 more than 3 times the base. So in for height, I'm going to put 3 times the base plus 5. And really, I'm happy if you get to here. What I'm trying to show you here is, when you're modeling, you have to figure out what equation are you modeling. Okay, so they'll give you the equation. It's not like the wind speed where it's like random. It'll be area of a triangle, area of a rectangle, something that should be part of your repertoire of knowledge. That's a good way of saying that one. And then what you'll want to do is always write that as a function of one of the variables, and there'll be 2 variables in here, so you have to replace one of them. Now, I'm okay with this as an answer. I think the textbook multiplied through, so they did a 1/2 b times 3b, which would give you 3/2 b squared, and then 1/2 b times 5, which would give you 5/2 b. So this may be the answer. Area as a function of base is 3/2 base squared plus 5/2 base. But again, I'm happy with either of those. If you can get to here, awesome. This is bonus, but we'll be doing this in chapter 3 anyway. All right. The next one, very similar. So we have a pig pen. There is 890 meters of fencing to enclose Porky's rectangular pork pen, or pig pen. If the enclosed area is x meters long, express its area as a function of its length. Whew. Now, these might feel confusing, but when you go to do your homework, they're going to be identical to this one. Now, this one the last one I didn't draw a little picture. This one I feel like needs a picture. You have a rectangular pig pen. The enclosed area is x meters long, so this is the length. I don't know the width. But I know that this is the variable I want. I want area as a function of length. So somehow I need to replace this width. So I'm going to start by saying area is equal to length times width, and somehow I need to replace this width because I want area as a function of its length only. Now, I also hate that the textbook always says length is x. I'm like, just let length be L, but whatever, it's fine. Okay, so if you use length as L, that's fine. But how am I going to replace width? What else have they given me? Well, they've given me this 890 meters of fencing. What is that? Well, I have 890 meters of fencing to go all the way around the perimeter. Ooh, I just said it. The 890 meters is your perimeter of your fencing. So hopefully you guys know that perimeter of a rectangle is twice the length plus twice the width. They're giving you that the perimeter is 890. Now they want us to do length as x, so let's put x in for L. And then what we want to do is we want to solve for w in terms of x. So I'm going to minus the 2x equals 2w, and then I'm going to divide everything by 2. That's going to give me 445 minus x is equal to w, and then that's what I'm going to put in for w. So w is the 445 minus x, and I'm going to plug that in. So again, area as a function of x, where length is the x, and the width is 445 minus x. And again, I'm happy if you stop there, but I do think the textbook multiplies through. So 445x minus x squared, or you could answer it as negative x squared plus 445x. Totally up to you. So any 3 of these, I'm super happy with. All right, let's try another one. Area of an office space. A community college has 30 feet of dividers with which to set off a rectangular area for a student testing center. If a corner of the math lab is used for the testing, the partition need only form two sides of the rectangle. Express the floor area as a function of the length of the partition. If you feel confident, pause the video and give this one a go. Otherwise, I'm going to draw a little picture. So we've got a corner of the math lab, which is going to be set up with partition. So this is my rectangular math lab. But what's going to happen is that you only need two sides to be dividers. So let's see if we can set this up. So here's my little picture. I know that I want to express the floor area of the office space, which is, oh, it's funny it says office space and office space. It really should be testing center. Same idea. I think I might have taken this question, I took it out of the textbook, and I wonder if it said that office space and testing center are synonymous here. Okay, so if express the floor area of the testing center as a function of the length of the partition. So anyway, the shape is a rectangle. Area equals length times width. Now I want area as a function of length. So again, I can have an L, but I need to replace the W. So in the last question, they gave us the perimeter of the pig pen. This time they give you, again, how many dividers you have, but the difference here is that the dividers are only going here and here. This is my length and this is my width. And I have 30 feet to go for both of those. So really it's just L plus W is equal to 30, because it's not 2L and 2W because these aren't included for dividers. So again, I want to replace the W, so I'm going to minus the L, and I get 30 minus L is equal to W, right? I minus L minus L. So in for the W, I'm going to put in 30 minus L, and again, I am super happy with this answer. If you multiply through, great. If you want to write it in descending orders of power, great. Okay, it does not matter. In chapter 3, you'll do this because then we'll be solving the quadratic equation. But in tutorial 1, we're just learning how to set up functions. Okay, the next thing, just to give you a purpose for this, the graph of the function is shown to the right. And I want to determine the dimensions that yield the maximum area. Really what I care about this is that if I show you that I'm modeling area as a function of length, that this vertical axis is area and the length would be your x-axis. That's really like, yes, this is a specific scenario. Yeah, sure, I want the maximum area or the dimensions that yield the maximum area, but really what I care about is that you know that when you're modeling, area is a function of length, area is your y value, and length is your x value. So my y-axis would be area, my x-axis would be length, and if I wanted to determine the dimensions that yield the maximum area, this is max right here, just the top. So at this max, my length is 15, and the width we already determined is going to be 30 minus the length. So the length that will give me a maximum area is 30 minus 15, which is 15. So determine the dimensions that yield the maximum area. Therefore, the dimensions are 15 by 15, and I believe this is in feet. Now, as an aside, what would the area be? Well, the area would be your y value, just like the length was your x value. So for max area of 225 feet squared, or square feet. Awesome. So this is the section of the chapter that usually gives people the most problem. I hope I've given you enough examples that when you get to the textbook, you're like, huh, this is identical to the one that Karen did, just different numbers. So don't stress too much about these. I purposely chose ones that were just area. So yes, it can be a triangle. Yes, it can be a rectangle, but I won't do anything too crazy. Really, I'm just trying to get you to realize that when you write an equation, you know, first step, right? When you first learn math, you're like, area is length times width. Well, when you're solving algebraically, it's too many variables. So we have to get rid of one of them, and that's what we're doing here. So this is area as a function of the length, where length is x, and then this one is area as a function of length. I let length be L. Awesome, good luck.